What is Ptuin A? Ptuin A is a glycoprotein secreted by the liver that modulates insulin action in adipocytes and skeletal myocytes. It is a multi-purpose protein naturally found in the body. It contributes to research in tuberculosis, childbirth, chronic inflammation, diabetes, and neurodegenerative diseases. It is researched by people wanting to use it as a biomarker to develop new drugs and to understand our biological systems. Now, there are some new studies about Ptuin A. The first one, titled Ptuin A negative acute phase protein linked to adipose tissue function in parturient or lactating dairy cows, by the Dairy Science Association. They found that protein decreases after lactating. The amount of protein affects inflammation after lactation. This helps scientists figure out why some cows lactate early and then become insulin resistant. Now back to humans. Another study is titled Serum Ptuin A Levels in Patients with Bilateral Basal Ganglia Calcification by Neuroscience Letters 2018. Findings are that the ganglia calcification plays a role in neurodegenerative diseases, and Ptuin A levels should be used as a biomarker to track inflammation. Also, Ptuin A levels are lower in Alzheimer's patients. So now, what is the biochemistry of Ptuin A in tuberculosis? From the liver, Ptuin A enters the plasma bloodstream and can be used as a tracker to measure inflammation and fatty levels within the body. Plasma Ptuin A levels were significantly lower in patients with active pulmonary TB rather than in the control subjects. Identifying levels of inflammation can help identify severity of tuberculosis, and an increase in fat levels can signal improvement in treatment. So now, what is the biochemical role of Ptuin A in childbirth? So, increased Ptuin A levels can cause adverse reactions during childbirth as a result of too much inhibition of the tyrosine kinase activity, which debilitates the invasion of necessary trophoblasts. The small trophoblasts are crucial for delivering nourishment to developing fetus. Too much Ptuin A prohibits these nutrients. So now, what is the biochemical role of Ptuin A in chronic inflammation and diabetes? Ptuin A can help understand insulin resistance by acting as an endogenous ligand that allows a pathway to the current non-existent and insulin-resisting FFA and TLR4-MD2 complex. As you can see in the second animation, with Ptuin A as an endogenous ligand, insulin can pass through the membrane with ease. So now, what is the biochemical role of Ptuin A in neurodegenerative diseases? As noted previously, Ptuin A can act as a biomarker for diseases like Alzheimer's. This can be useful in genetic counseling. Now let's look at the study Effects of Increased Ptuin A in Human Trophoblast Cells and Associated Pregnancy Outcomes. Specifically, let's look at the experiment behind Figure 4, invasiveness of EBT cells exposed to trophoblast growth factors and Ptuin A. They did an invasion assay. The control cells were placed into an invasion chamber, and the cells permeate into the membrane and are stained and treated with 10% acetic acid. This allows invasion of the membrane to be measured using colorimetric absorbance. Level of invasion can then be determined and compared using a few different methods, such as measure of density or number of dyed cells. More specifically, let's look at EBT cells, growth factors, and the controls used in the experiment. The experiment was conducted using in vitro EBT cells obtained from first trimester placental tissues. The chronic villi from the EBT membranes were then minced and cultured at 37 degrees Celsius. After the cells were isolated into their chambers, they were exposed to commercial Ptuin A at increased levels over 48 hours. They added growth factors to the EVT cells, such as modified medium, epidermal growth factor, insulin-like growth factor, and placental growth factor. They used two controls, EVT cells that were exposed to a media that did not contain FIT2A, and EVT cells that were exposed to a blank buffer. They did not use fetal bovine as that contained FIT2A already. The y-axis is labeled normalized invasion measures the invasiveness of permeable membrane by a measure of optical density values. Then the x-axis shows the comparison of the exposure of the trophoblast growth factors, black bar, and then the corresponding increase in added FIT2A levels, which is the white bar. Let's look at the findings. Based on all the experiments in the study, the results indicated that high concentrations of FIT2A in cell media decreases the viability and invasiveness of human EVT cells. The data in Figure 4 supported and led to the conclusion, yay! It was found that the added trophoblast growth factors increased the level of invasion of EVT cells through the membrane, confirming that different growth factors should be used to support or increase the invasion of EVT cells into the membrane. Looking at future directions in research with FIT2A, let's focus on pregnancy outcomes using methods like mouse models and evasion assays like before. A possible experiment would be looking at women with diabetes, as diabetes patients have higher levels of FIT2A in their system. The experiment would include diabetes drugs, an invasion assay on treated mice, and EVT cells extraction from mice. Variables might include diabetes drugs versus a placebo treatment and measuring FIT2A levels after treatment. Some controls may be pregnant mice with diabetes and EVT cells exposed to diabetes medication, and mice not exposed to diabetes. We would be looking to see if we could see significant differences in preeclampsia rates in mice and how diabetes and FIT2A affects the risk of preeclampsia.